Good day. Today we will be looking at June 2022, paper 2, question 3. In the diagram, it reads in the diagram A, coordinates 5 to 3, we've got B, 0, 1 to 2, 0 and a half, and then we've got C, we've got D in the middle, and we've got E, 6 to negative 4, and they show us that CD is equal to DE. Okay, I think I'm gonna draw it out. Okay, no, we're gonna draw on here. So let's read our first question. Our first question says calculate the gradient of AB. That's a fairly easy question. We know our gradient formula. If you don't, you're more than welcome to go and look for it in the formula sheet. Let's go familiarize ourselves. So here we've got the formulas that we would use in analytical geometry: straight line, and here's our gradient. This can also be used when we want to solve the gradient or one of these variables. Here we've got midpoint, and here we've got distance. Okay, let's go back. Okay, calculate the gradient of AB. So gradient, we're going to have y of A minus y of B over xa minus xb equal to, so y of A is 3 minus a half over x at A is 5 minus 0. And this, if you put it into our calculators, go straight to your calculators. 3 minus 0.5, 5 minus 0 gives me a half. Okay. The next question says determine the equation of CE in the form of y is equal to mx plus c. Okay, so another thing that they gave us is parallel lines. Let's just highlight those. So we've got this parallel, AB is parallel to CD. Now that is very useful in this question because they want us to find the equation. And what do we know about parallel lines and the gradient? When we have parallel lines, the gradients are equal. So the gradient of AB is equal to the gradient of CE, which is a half, and that's because AB is parallel to CE. So we have the gradient, now we just need the value of C, which we can substitute using E. So we're going to substitute the values of E, which is 6 to negative 4. So we got negative 4 is equal to my gradient is a half. X is 6 plus C. A half times 6 is 3 plus C. We're going to take the 3 to the other side, so we've got negative 4 minus 3. C is therefore equal to negative 7. Make sure you write out your final answer, which is actually the equation. So it's y is equal to a half x minus 7. Okay, our next question, 3.3.1, says calculate the coordinates of C. They want us to find the coordinates of C, which is also a fairly easy question because they have already told us that D is the midpoint, so we're going to use midpoint theorem. The only thing that we would need is these coordinates of D, but we also know that the coordinates of D is what of CE? It's my y-intercept. So therefore D coordinates is 0, negative 7, because my C value is negative 7. We know E is 6 to negative 4. Now we can use midpoint theorem to find our value. So x of C plus x of, let's see, of E over 2 is equal to x of D. That's how we're going to work. and y of c plus y of e over 2 is equal to y of d. Now we can substitute. So x of c is what we're looking for. X of c is what we're looking for. We know our x of e is 6 over 2 is equal to x of d, which is 0. So what are we going to have here? We're just going to have x of c is equal to -6, because the 2 times 0 would be 0. Y of c is what we're looking for. Y of e is -4 over 2. Y of d is -7. Cross multiply. 2 times 7 is -14. Y at c, we're going to take the -4 to the other side, plus 4. So y of c is -14 plus 4, which is going to give me -10. Therefore, my coordinates of c is -6, -10. Okay, let's fill that in so we don't get confused with what we have been given and what we are calculating. So we just calculated c to be -6, -10, and we know that d is 0, -7. Okay, now let's look at our next question. Next question says the area of quadrilateral ABCD. Okay, let's highlight that. The area of quadrilateral ABCD. Okay, so that is what they want. So we're obviously going to have to split this into two triangles. The first triangle being BCD and the second triangle being ABD. We also need a base. So looking here and a height at ABD, I can see my height here is going to go from 7 to 1/2. So it's going to be 7.5. Let's zoom in. We're looking at BCD. So I'm saying my height, which is here, is going to be from the 7 to 1/2. So it's 7.5. And the length of this is from 6 to 0, so it's 6 units. Okay, and I've got a base and I've got a height. If we're looking at the other triangle ABD, here my height is going to be the same, 7.5, and here my distance is going to be 5 units, from 0 to 5. Now that we have that, we can use to calculate. So they are asking us for the area. So we're calculating area of BCD first, of triangle BCD. That is 1/2 base, my base, and my height. So I said it was 7.5 and 6. Let's use our calculators. 1/2 of 7.5 times 6, that is going to give me 22.5. The next triangle is area of triangle ABD. It's 1/2, 7.5 and 5. We have 18.75. Therefore, my area of ABCD is 22.5 plus 18.75. Let's calculate that. 22.5 plus 18.75 is 41.25. Make sure you keep your answer as units squared. Okay, let's look at the next question. Next it says, if K is the reflection of E in the y-axis, write down the coordinates. Okay, so let's go here. You're saying that K is a reflection of E, but only in the y-axis, which means it has the same x-axis value. It's just maybe the sign is going to change. So let's go across. Okay, so C is also is 6, so it's going to be -6. My x, because my x value is not changing, the sign will just change, but we're reflecting along the y-axis. So my y value is going to now change. Is now going to be the same, which is -4. We're reflecting along the y-axis, so y stays the same, x, the sign will change. Okay, sorry, that was what I meant initially. So when we're reflecting along the y-axis, my y value remains the same, my x value stays the same, but the sign changes. If I'm reflecting along the x-axis, I'm going above or below the x-axis, the y value sign will change. Okay, so now we know the coordinates of K. So this is 3.4.1. K is going to be -6, -4. The next question says, calculate the perimeter of KEC. So they want us to calculate perimeter now, not area, of K to E to C. KEC. So let's take a look at what we have here. So if we look at KC, the units, it's going, so when we're looking on the y-axis going from up to down, we're looking at my y values to find the distance. So here we've got -4, -10. So -4 minus -10 is going to give me 6 units. And I'm going to write that out now. And if we look at KE, it's horizontal, it's perfect. So we're looking here at my x values. So -6 minus 6 is going to give me 12. So that's 12 units, but we don't know CE. We have to calculate CE using Pythagoras, and then we can find our perimeter. So let me repeat what I just said. When we have a value on our axis, so let me draw this out. We have K, C, and we have E. K and C have the same x values, and K and E have the same y values. So when we are working from up to down or down to up, we will add, technically we're going to add the values or use the values that are not the same. So when we're working from up to down or down to up, we're working with y values, and when we're working across, we're working with x values to find the distance. So looking at KC, we've got -4 minus -10. So it's going to be -4 plus 10. It's going to be 6 units. Looking at KE, we said we're working with our x values. So -6 minus 6, it's -12, but we don't have a negative value for units, so it's 12 units. And what we have to calculate next is CE, which we don't have, which we're going to use Pythagoras. Okay, so CE is equal to the root of 6 squared plus 12 squared. And we can go straight to our calculators with this. 6 squared plus 12 squared. It's 6 root 5, which is 13.42. And the question actually asked us for perimeter. So therefore perimeter is equal to 6 plus 12 plus 13.42, which is going to be equal to 13.42. 31.42 units. Okay, and we have one more question left, which is 13.42b, and they want us to calculate the size of KCE. So technically my angle that is here, KCE. And because we have a Pythagoras triangle, I'm going to say we work with that Pythagoras triangle and solve from there. So we have this triangle here. We want this angle here. So we can use sine, cos, tan. So what ratios am I going to be using? It's situated here. So I can use opposite, I can use tan opposite over adjacent, or I could use either sine, cos, or tan because I have all the values, but I'm going to work with the values that's not a decimal, so I'm going to use tan. So tan of angle C is equal to 12, because KE is 12 over KC 6. I'm going to use our calculators, so that is equal to 2. So shift tan 60, so my angle, which is angle C, is equal to 63.43 degrees. Okay, let's take a look quickly at our mark allocation. Okay, the first question that we had, where we had to determine the gradient, was just 2 marks. 1 for substituting into the formula, and 1 for your answer. The second one, where we had to find the equation, number 1 for knowing the gradient, and that is because you had to know the rule of parallel lines. The second was for substitution of the values of E, and the third was for your answer. That was 3 marks. 3.3.1, we had to find the coordinates of C using midpoint. You had to first know your coordinates of D, that was 1 mark, and then a mark for your X value and a mark for your Y value, 3 marks. And then the next one, we had to find the area. We had to separate them into triangles, so 1 mark for the area of BCD, 1 mark for the area of ABD, and the final mark for your answer. Oh, and another mark for substituting the correct values for your bases and heights. So this was a 4-mark question. Then the next question was just your coordinates of K, but it was a 2-mark question for each of the coordinates. The next one was finding the perimeter. So you had 1 mark each for knowing KC and KE for figuring that out, another mark for CE, and another mark for your answer. 4 marks. And the last one was the angle that we calculated. It was 3 marks, 1 for your trig ratio, 1 for it equaling to 2, and 1 for your answer. And in total, our question total was 21 marks. Thank you.